All right. We've got 3 more weeks of class, I think.
That's not good.
1, 2. Yeah, we got maybe 2 weeks and a half left worth of class.
That's not good.
What's not good?
Oh, that's a little time.
Yeah. Thankful. I mean, I don't want to say thankfully. I mean, kind of. The last couple of sections, like after we get over 7-1 and well, just 7-1 really. After we get over 7-1, I think the rest of the chapters or the sections. Oh man. I forgot to do something. Hold on. Ah, man. For those of you with allergies, don't forget your allergy medicine. Oh, man. I just noticed I was rubbing my eyes like a little too roughly. So, you guys are going to see me take an allergy pill. Don't forget your allergy pills. After section 7-1, it's actually pretty quick. I think we're going to be able to get through 7-2, 7-3, and maybe 7-4 within like, I think we could do those in a day, if not a day and a half. So I think we'll be by 7-4 by the end of this week, actually. They're literally like equations that we're going to use. So like I had mentioned to you guys earlier, right? This big, huge packet down here, right? Your trig trifold, which you guys should have printed out by now. If not, do it soon. We're just learning all the stuff that's on here and how to use it. That's it. And it's pretty much smooth sailing from here on out. Okay. There is going to be a bump at 7-4, or sorry, 7-5, which I don't have up yet, and I will have it up by hopefully by tomorrow. Well, we probably might slow down. Okay. So yeah. Okay. Housekeeping, online homework. So I took a chance. I took a look over the homework assignments, the online stuff, and the lecture questions. Question on the chat box. It should be in your files. There should be a Word version in your files. If not, what I can do is I can maybe change it into a PDF. I think the PDF is in there too. I mean, I'll check it during break. How about that? And if it's not in there as a PDF, I'll change it into a PDF. You see it? Okay. Does it open? At least. Yeah. Okay. Woo-hoo. So that trifold is for your guys' reference. I'm not going to ask you guys to memorize it, but you will need to know how to use it. So make sure you start becoming familiar with it when you guys are doing the homework. Make sure that's like right next to you guys, okay? It's very helpful in referencing stuff. You guys will see all the stuff that we're going to do in the next couple sections. It's going to be repetitive, just repetitive stuff. But it's all going to be sort of like new stuff. Every single time that you use trig stuff, right, you learn a new trick or you learn a new thing and you get better at that thing so you can use it later and so on and so forth, right? And all that comes from like referencing stuff and being able to know how to use it properly, Okay, so just keep that out. Back to the thing that I was saying. I took a look at lecture questions and the online homework. For the most part, everybody's somewhat behind, but not as behind as some people think. I do want to put out a warning. I don't think. Well, let me just put out the warning. There are people in here that have like a passing grade, so they have a 75, 80% for the class, right? Only because they've only finished up to chapter 4. And not even the entire thing. They're like at 4.2, 4.3. Okay, and we're currently in chapter 7. So those people, if you know who you are, make sure you catch up. Okay, which brings me to my next point. There's rolling homework closures. So chapter 3 and chapter 4, I'm going to be closing up soon. So if you are one of those, there's some people in here that have a passing grade because they finished up to chapter 3, and that's it. Okay. You have until the end of this week to finish all that stuff up. Okay. Make sure you get it done. That's I'm if you guys need lecture what is it late passes, if you guys need late, I just gave you guys 100 of them, so use them, get it done. Okay. Let's see, lecture questions, make sure you turn those in. So those are the ones you have to take a picture of. Labs, the lab assignments for chapters 5, 6, and 7 are up, and chapters 4 and 5 is up too, but I made that extra credit. So if you guys finish that assignment, it'll be extra credit for that section, for your lab section. Okay. Chapter 4 not accessible that time. So now I think the ones in chapter 7 I fixed. Chapter 4, let me know which ones they are. I'll do it during the break. Okay. Okay. Any questions from you guys for any of this stuff? Anything at all? Anything at all? Okay. Okay. Let me turn my camera off. You guys look like my little picture that I found?
Yeah.
Happy May the 4th, everyone. Watch a Star Wars movie today. Except that last one, because it was horrible.
Really?
I didn't like it, man. It rushed it all. There was no there was no wonder in it. There was no imagination in it. It felt very contrived.
I think they should have kept him alive and then had a baby.
They what?
I think they should have kept him alive and had a baby.
Yeah.
That would have been great.
Yeah.
That'd be one evil fucking kid.
It would.
That'd be like the kid off of Twilight.
Mm-hmm. Okay. I'll check that stuff, Mohammed, during the break time. I just started watching the Twilight ones over the weekend.
Oh, yeah.
And I don't know how people, I don't know how little tweens can get in. Well, I can understand why little tweens can get into it.
Probably because of Jacob.
Yeah, that kid can't keep his shirt on.
Yeah, I wish I couldn't keep my shirt on.
Yeah. All right. Yeah, watch a Star Wars movie today, except for the last one, or the cartoons. The cartoons are pretty decent. What I want to start with today, I want to finish up that one problem that I royally screwed up at the very beginning, or at the very end of last class that I was trying to finish up, and it took forever. And it turns out it was much simpler than I had pictured it to be. So I want to finish it up in front of you guys. I swear I'll do it right. And then we'll wrap up section 1. I think we already did that, the quick check that came after my screw up. And then we'll go ahead, I'll give you guys some time to do the lecture questions, and then we'll do 7.2 and wrap it up all in one day. So in that way, tomorrow we'll do 7.3, 7.4. And we might be able to call chapter 7 by the end of this week. I think. All right, let's go ahead and finish that thing. So notice how I left myself some notes this time. I don't screw it up. How much battery do I have? Oh, heck no. Yeah, that's where it should be. Okay. All right. So my notes say to switch it all to sines and cosines. And there's a reason why. So as usual, you guys can stop me whenever you need me, okay? If you need me to answer something specific. Let me erase my nice derogatory note to myself there. All right. So notice my note, it says I needed to switch them all to sine and cosine. If you need to, that might be the thing that you need to do, okay? So don't hesitate to do that. This should be, I will tell you guys this right here, should be your very last resort, switching it to sine and cosine, because it makes it much more complicated because you're splitting up one nice clean thing into multiple things, right? So switching it all to sine and cosine is your last resort. Try to use any and all identities you can from that trifold packet that I gave you guys before trying this out, okay? So this one requires you to switch them all to sine and cosine, okay? Same thing, I'm gonna start with the left side, okay? So then this is gonna be, cosecant is 1 over sine of x. Right? Minus cotangent, which is cosine of x over sine of x, right? So that's just gonna be the top divided by the bottom. Secant is 1 over cosine, right? And then minus 1. That's going to be the bottom, right? Okay. I'm going to grab this one right here. I'm going to do some common denominators on it, and I'm going to start combining stuff over one single denominator. So the top now is going to be this: 1 minus cosine of x over sine of x. Okay, and then the bottom, I'm going to keep that 1 over cosine, and then I'm going to change that minus 1 into minus cosine of x over cosine of x. Notice I did nothing out of the ordinary here, right? So then now, equal 1 minus cosine of x over sine of x divided by 1 minus cosine of x over cosine of x. So notice I did nothing out of the ordinary here, right? All I did was common denominators and then put them over a common denominator, right? So now I have this going on. 1 minus cosine of x over sine of x divided by 1 minus cosine of x over cosine of x, right? So I have here a division of fractions, right? Which means I can flip this second one, right? And then make this into a multiplication. So this becomes 1 minus cosine of x over sine of x, right? Times cosine of x over 1 minus cosine of x. You guys see how pissed off I am now? So there's a multiplication here. I have one on the very top, one on the very bottom. I get left with cosine of x over sine of x, which is equal to cotangent. We are done. So notice what we did, right? We turned, come on. My tablet's acting up again. There we go. We turned this side. We turned that left-hand side into that right-hand side. So once we get there, we're done. Okay, now notice what I did here, right? All the math that I did, all of this stuff, all of that stuff, right? The actual math that I did was secondary to sort of the logic that I had behind my steps. Does that make sense? I was able to explain every step. My steps made sense as I went through the problem, right? The way I did that, so common denominators, flipping the fraction, making it a multiplication, all that stuff, that all was secondary to explaining my next step. Make sense? You guys got to get used to that now. Okay? If you don't know why you're making the next step, right, then don't make it. Think it through. Okay? So notice how short and sweet that was. I had mine going like way over here, making it all nasty. And it turned out to be 3 lines. Look at that. Crappy, right? All right. Let me take a look at what's coming up. Okay, so what we're gonna do now, actually, I'm gonna skip this one. I'm gonna move on to simplifying trigonometric expressions and solving equations for them, okay? So for these, so we can solve equations with sines and cosines. They're not sort of things that sort of exist on their own. They can exist within algebraic expressions, okay? And the way that we're going to solve these, right, is by using the same stuff that we were using before, but now we're going to hit it with some unit circle stuff. That's it, okay? So, for example, we have this equation right here for A, right? So I can do, what I'm going to do is I'm going to use here's the magic word right here. We are going to be factoring in this case, okay? So what I'm going to do is I'm going to set it up in a method, in a way so that we can get a polynomial, okay? What do I mean by that? So I'm going to grab all of this and move it over, okay? I'm going to get this now. 2 cosine squared theta minus cosine of theta plus 1 is equal to 0. Now, it looks like I might have made it a little more complicated, but in fact, I sort of didn't. So this, like, if you think about it, right, this, we can think about it as this. 2x squared minus x plus 1 is equal to 0. The only difference here is that x now is my cosine of theta, right? I can factor this into something nice, okay? And that is the 2x minus 1 and x minus 1. So if we notice, if you guys remember the distribution, right? If you FOIL it, right, you'll get 2x something went wrong. Something went wrong. Here we go again. X minus x, that's minus 3x. I think this is supposed to be a plus. So typo. Make sure you make that change. So then this becomes a minus. And I think that fixes it. Yep. So then this becomes a minus and this becomes a plus. That's what I meant to do. It's 2x plus x. Yep, that'll work. So make sure you make that change. So it's supposed to be cosine theta plus 1. So now, why the heck did I do this? We know that from sort of here, right? We were treating it as a polynomial, but in fact, x was cosine. So then this means that my original problem is 2 cosine of some theta, right, plus 1, cosine of theta minus 1 is equal to 0, right? And now we can do the same thing that we were doing before. We had to set each one equal to 0 to find our answers, right? So the first one I'm going to do is this. Cosine of theta minus 1 is equal to 0. So that implies cosine of theta has to be equal to 1. Okay? What angles does cosine give you 1? Any guesses? Notice how we're going backwards now on the unit circle. Whoop. Not what I wanted to do. No, actually, that was exactly what I wanted to do. So if we take a look at a unit circle, right? Cosine is 1 only here, right? So we can go back to our original problem. So theta, our angle, is 0 and 2 pi. Those are our two angles for that one. And now the second one, with 2 cosine theta plus 1 equals 0. Okay. 2 cosine of theta plus 1 is equal to 0. Okay. So then cosine of theta, 2 cosine theta, is equal to -1. Cosine of theta is equal to -1 over 2. This looks nice. -1 over 2. We need angles such that when you take the cosine of it, it's equal to -1/2. So again, back to the unit circle. Notice how we're going back to this like repeatedly, right? We need it such that cosine is -1/2. We need cosine being -1/2, right? That happens here and here. That gives us our angles. That right there, and that right there. So those are the only two angles that do this. So dang it, I forgot which ones they were. 2 pi over 3 and 4 pi over 3. Okay. So then theta is equal to 2 pi over 3 and 4 pi over 3. So our answers for this equation are those two and those two. So this answer, or this equation, has 4 different answers. Okay? And notice these happen by factoring. Okay? Okay. The next one. This one's actually a little simpler. So we've already got it in a nice way. So I'm going to -1, whoops, -1, right? Square root of 2 sine of x is equal to -1. Divide by root 2, divide by root 2. Sine of x is equal to -1 over square root of 2. No square roots on the bottom, so multiply root 2. And if you do this right, this is going to be -√2 over 2. So I'm going to write it up here. We need sine of some angle to be equal to -√2 over 2. Okay? Again, we'll go back to our unit circle. We need angles such that sine of that angle is equal to -√2 over 2. Right? That happens here and here. So that spits out the angles that I need. That one and that one. So I go back to our thing, to our original problem. So the X angle has to be 5 pi over 4 and 7 pi over 4. Got it? Okay. All right, these don't have a number on them, so how about this? Since there's not too many of you guys here, I'll split you guys into 3 groups. And how about we do, I'll make, actually make it nice and big. I'll make this one 1, 2, and 3. So some of these might require you guys to, no, I'll do this. 1 and 3 for this one, and group 2 for this one. Yeah. Okay. I'll let you guys try this out. And we'll try out the next ones separately in about 5 minutes, okay? So I'm going to break you guys up into your groups. I want you guys to try these 2 out, depending on what group you are. So your group number tells you what group you're going to be in, okay? Steiner. Thumbs up, thumbs down, thumbs middle.
I think like middle.
Middle.
Yeah.
Okay. You still having trouble with it or? Nah?
I haven't finished it, so I
Okay.
don't know.
Okay. Okay. I'm gonna let you guys dabble with it a little more.
Okay.
Okay. How you guys doing? Thumbs up, thumbs down. Easy to follow along, not really. Silence. Whoa, oh, 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 oh. Sometimes I wonder how often there's like silence in one of these rooms and one of you guys is just like throwing your computer against the wall or something. Try to replicate the thing that I just did for you guys are group, which one? 3. So yeah, that's just like a example, like the one right above it. I think it's B. Yeah, that's B. Try to replicate that. And we'll come back together in a little bit to discuss them.
Are the answers going to be similar?
They might be.
I think I could follow. I followed along with the last half of the problem,
Right.
the unit circle part. It's just the factoring part that I don't know how to do here that well.
So we're not there yet, but we will be.
So were we supposed to factor this one out or no? Oh.
Not this one. See, this one doesn't have squares in it, right?
Oh. So you factor out the ones with squares.
Yeah. So this one we don't. Like I said, there's no squares in it. We don't get to turn it into a polynomial, right? So this one's not going to be like A. Most of these are actually like B.
Okay.
You guys feeling okay with it? And silence. the very least, Joe, just keep following along. Okay, I'm gonna go mess with another group really quick. And I'll bring everybody back together. Who's left? Okay, I think it's them. Yeah. Thumbs up, thumbs down, thumbs middle.
I couldn't get past the tan 3 theta equals negative square root 3 over 3. I don't know how to get rid of 3 in front of the theta. Would I just get rid of tan?
So, no, you're exactly where I thought you would have trouble.
Oh.
So, you know the angles, what angles give tan root 3 over 3? So what angles do that?
Oh. I'm not too sure.
Mm-hmm. So you got down to where you need to solve it, right? I think if I gave you the angles, you'd know what to do next. So if you, so root 3 over 3, right?
Mm-hmm.
Happens at, I'm thinking, yeah, happens at pi over 6 and 7 pi over 6.
Wait. 7 pi? 3.
Yay or nay?
Because tan is sine over
Cosine.
over cosine, right?
Yep.
So sine. Oh, okay. Okay, so once, but will we just leave the 3 in front of the theta? Oh, we got it.
So you need angles, right?
Mm-hmm.
Such that you need angles such that the tangents of them, right, is pi over 6 and 7 pi over 6, correct?
Mm-hmm.
So then you can grab, so basically each one of those, so it's going to be 3 times other angles, right, have to be equal to those angles.
Oh. Wait, so, oh, I got negative square root of 3 over 3. So would that be actually 11 pi over 6 and 5 pi over 6 because it's negative?
It is negative. So it would be, yeah, it would be, sorry, that's my bad. 5 pi over 6 and 11 pi over 6. Yep.
Okay.
Got it?
Yes.
Okay. Let me call people back.
Okay.
Were those hard? And if you guys have Disney Plus, then the new Star Wars movie comes out today. Disney Plus. Everybody? Yep. All right. Okay. Screen. I wonder. There are usually certain people on here that. No. Okay. All right. Let's keep going with this. So this one was. These are a little. I may not say. There was an added step. There was an added step. Okay. So let's do number 1 first. So what'd you guys do? What you guys do? Besides throw your computer at the wall.
Yeah. Fuck.
So let me go ahead, just go do it since you guys are a little shy. So I'm going to move the +1 over. So I'm going to get cosine of theta over 2 is equal to -1. Okay, so here's where we can go back to our unit circle. We need cosine to be equal to -1, right? So we'll go back to our unit circle. Cosine is equal to -1 only right here. Is it? Did I really screw this up? Let me see. Yeah, +1. +1. So we look at where cosine is equal to +1, right? And that is only right here, right? Which gives us our angles. It's going to be 0 and 2 pi, right? So we can go back to this thing. So here's the added step, sort of, right? So that means theta over 2 has to be equal to 0 and 2 pi. Right? Now, I still have that divided by 2 there, right? So I can go ahead and multiply by 2 on both sides. So here, I'm multiplying both things by 2. So that means theta is 0 and 4 pi. And those are my answers. Okay. Likewise over here. Likewise over here. -1, √3 tangent 3 theta is equal to -1 divided by √3 tangent of 3 theta is equal to -1 over √3. And if you guys rationalize it, it's going to be -√3 over 3. So we need tangent of 3 theta is equal to minus root 3 over 3. Okay? We need angles such that when we take the tangent of them, it's negative root 3 over 3. Okay? That happens, we're going to go back to our unit circle. So tangent, angles such that tangent are equal to negative root 3 over 3, right? So if we take, you guys notice this, 1/2 divided by negative root 3 over 2, that's going to be negative root 3 over 3. And then likewise over here, it's going to be the other one. So we have our angles. It's going to be that one and that one. So 5 pi over 6 and 11 pi over 6. So 3 theta is 5 pi over 6. My pen is acting up again. And 11 pi over 6. Okay. So here's the very last step. I have that 3 times pi that's right here, right? So I can multiply by 1/3 on each side, right? And that gets rid of stuff, right? So this gets rid of that, and I get left with now theta 5 pi divided by 6 times 3 is 18, since I'm multiplying it by 1/3, comma, 11 pi over 18. And we have our answers. How does that feel for people? Not too bad, okay. Okay, so I want to try the same thing for these two down here, okay? These are going to have square roots in them, okay? You don't need to do substitutions yet, but there are square roots in them, okay? So, actually both of these, I'm going to switch these around. I'm going to do 1 and 3 here and 2 here, okay? These require trig identities. So if you guys remember from 7 or 6, are they at the beginning of this section? Yeah. So you guys are going to need some versions of this, of these 3 right here. Okay. So I'm going to break you guys up into your groups one more time. And you guys are going to try to solve these 2. Okay. Manipulate any one of the equations from the very beginning of the packet of this section so you can get what you need. Okay. And you guys are off. Thumbs up, thumbs down, thumbs middle. I swear this is the last big thing. This is the hardest part of this chapter. Okay. I'm gonna take it as you guys are still crunching it out. Thumbs up, thumbs down. Or are these a little harder?
I just came here like 12 minutes ago, so I have no idea.
Did you oversleep again?
Yeah, I did.
Oh.
I didn't. Oops. I took a nap yesterday,
Oh.
and I couldn't sleep until like 3 o'clock in the morning.
Oh no.
So yeah.
Yeah.
I'm trying to look at. I'm on the what you call it. I'm looking at the
Oh, the
live
notes?
notes right now. Yeah.
Yeah.
And I'm just trying to.
Figure them out.
Yeah.
Okay.
Do you need to look at example 8, or is it actually just
No,
from
yeah,
the start?
it's similar to example 8, the one with the A and B.
Okay.
Yeah. Okay.
So do I have to move everything to the left and then make it equal to 0?
Yes. Well, no, not make it equal to 0.
Or-
Actually, try example B. So these
Example
ones
B.
that I'm giving you guys, you need some of the trig identities for them.
Mm.
So those at the very beginning of the packet. Okay, let me mess with one other group and I'll bring everybody in. Seems like people are, I think I broke people. I think I broke people. You guys.
Are these ones similar to
These are
A?
still, these are not similar to A. These are actually similar to B.
Oh, geez.
Yeah. So like I said, grab your the some of the identities from the very beginning of the section. So that's let me show you guys the screen really quick. These. In particular, these right here.
Mhm.
So grab those. You might need to manipulate some of these, right?
Mhm.
And substitute those in to get your guys' equations.
Okay.
Got it?
Yeah.
Anything? You guys are still cranking it out?
Yeah.
Okay. Maybe give you guys another minute or so, and then I'll call you guys back in.
Okay. Is it you bring the -2 cosine 2 over to the sine part, and then that gives you that first equation right there that where it equals 1?
Close. So actually, for which one are you talking about? That's the. I'm letting my thing load. Which one did you guys get? You guys got.
The one below the first one. Oh wait, no, we're number 3. I'm doing the wrong one.
What does it
Whoops.
matter? If you want to keep doing number 2, that's fine too.
Okay.
But yeah, so if you bring, yeah, actually, yeah, you're right. If you bring the -2 cosine squared over, right?
Mhm.
You're going to have 2 cosine squareds on that side, right?
Yeah.
You can separate one out, right?
Mhm.
And then you have sine squared plus cosine squared, and that equals 1. Does that make sense?
Yes.
So like a big chunk of everything that you had on the page now just reduces down to just 1. I was thinking of doing it another way, but you guys will see, like, for these problems, there's more than one way to do it. Okay, I'm gonna call you guys back together. Cool?
Okay. Yeah.
Did you guys get stumped?
Yeah.
Real bad or me?
I'm kind of I think I'm on the right path, but I have no idea.
Well, we'll find out.
Okay.
Let's give people another minute to come back in. I know there were some people like really cranking it out in their groups. It's almost summer. It's almost summer. All right. Let me start with that first one. This one. Okay. So I did it one way, and somebody from another group did it kind of a little bit more cleverly than I did. A little bit more finagling, much more elegantly than I did. Let's put it that way. Okay. So, the big ones that I told you guys that you guys are going to have to use for these problems, for these last two, we're going to be, let this thing load. There's going to be those Pythagorean identities, the ones with the squares in them. These, okay? In some cases, you guys needed to manipulate them. In some, you could use them flat out, okay? So the way that I did that first one, I grabbed the first one, I manipulated it, right? And then I stuck it in as a substitution, right? Not entirely the same way that this person did it, but it's equivalent. So when you guys start doing these proofs and these solutions for these equations, there's more than one way to do it, okay? But most of them, I'd say, would probably line up in terms of the methods, okay? So one person did this. Actually, do this. This minus 2 cosine x, they threw it on the other side. So then now they have this. Sine squared of x plus 2 cosine squared of x is equal to 4. Right? Sine squared of x plus cosine squared of x plus cosine squared of x is equal to 4. All I did for this next step, there's 2 of them, I just split them up. There's nothing wrong with that, right? Now, the reason why that's actually helpful is now I have this thing right here, sine squared plus cosine squared. That I know is equal to 1. So now I have this, 1 plus cosine squared of x is equal to 4. Cosine squared of x is equal to 3. I think this is a bad problem. So then now I have this, right? Cosine squared, wait, let me actually do the step, square root. So cosine of x is equal to plus or minus square root of 3. Why did that show up there? I think I might have copied the problem wrong. Yeah, I think I might have copied the problem wrong. God dang it. Yeah, so this right here will have no solutions. So that means I must have copied this problem up here wrong. So annoying. So long as you get down to here, if you guys got down to this, that would be okay. I need to now go back and check every single other problem that all right. Hopefully we don't have the same problem with this one, okay? So this one actually requires one of the 3 Pythagorean theorem ones, the ones up here. So we have a cosecant, right? Which means this one. That's cool. This one right here. So we're going to change that left-hand side into 1 plus cotangent. So now I have this going on. 1 plus cotangent squared of x is equal to cotangent of x plus 3. Actually, this one is going to be like the one from A. So now, make it all equal to 0. So I think it was you, Jarek, that I told you that. No, this one's like B. No, it's like actually like A. So that's my bad. Okay, I'm gonna make it all equal to 0. Huh?
I was the one in group 2.
Oh, you're in group 2. Okay.
Yeah.
So at least I didn't screw that one up. Well, I did, but yeah. So I'm going to grab all of that stuff and move it over. Okay. So now I'm going to have this, right? A cotangent of x minus cotangent of x. So it's going to be minus 3 plus 1, so minus 2 is equal to 0. Cotangent squared. Do people need to see the steps there? Okay, I'm guessing not. So if you need to see the steps there, let me know. So now we have this thing going on, right? There's an x squared minus x minus 2 equals 0. This factors nicely to what and what? Any guesses from the crowd?
X minus 2, x plus 1.
X plus 1, does that work out? Yep, that works out. Make sense? So then, now, I can go ahead and substitute all my x's for cotangents, because that's what it was to begin with, right? So I have now this, a cotangent of x minus 2 times cotangent of cotangent of x plus 1 is equal to 0. Right? Here's where I split. So that means cotangent of x minus 2 is equal to 0, and then cotangent of x plus 1 is equal to 0. So then here, for the first one, cotangent of x is equal to 2. So I need sine divided by cosine to be equal to 2. So we go back to the unit circle. I think that actually exists somewhere. These aren't on the unit circle. I need to check my problems before I put them on here.
Did you say sine over cosine?
Or
did you
cosine over
mean-
sine. Cosine over
Yeah.
sine, sorry. Cosine over sine. Yeah, those points don't exist here. Because you'd need tangent. Yeah. Yeah, they won't exist here. Oh my God. We were doing so great until we got to here. So let me actually just. So I'll put this down. So this one I'll skip as an answer because cotangent is never going to be 2. Well, it isn't on the unit circle at least, right? But I do want to practice this one. The next one will give us some answers. This one will. What the heck? Okay. This one does. So we need cotangent of x to be -1. So that's cosine divided by sine. Okay? And those, let me go here. Cosine divided by sine have to be -1. So that only happens here and here. Right? So my angles are 3 pi over 4 and 7 pi over 4. So x, 3 pi over 4 and 7 pi. Over 4. So at least that second one does get us answers. Whoa. Okay. Oh man, that hurt. I should leave myself little notes. Okay. These, I think, are good. Yeah, I left you guys with nicer ones. Yeah, these are much nicer to do. So what I'll do is I'll give you guys maybe a half an hour, so about at 11:30, we'll come back together and we'll do 7-2. No, 7. Yeah, 7-2. Okay. Within that half hour somewhere, take a break for yourselves. Go have your Pablo Escobar moment. Walk outside, get some sunlight. Okay. So I'm still here. I'll be walking around in my apartment. Oh, actually, before I do that, so you guys are off. Go ahead and try out the lecture questions. I'll be still online answering questions that you guys might need. Mohammed, you still there?
Got my wife good.
You got your wife good?
Yeah.
Would
She
you-
was complaining about she can't get she needs to get her nails and she wants to get her nails and shit done. I said, go
Yeah.
spend as much money as you want on your nails and your feet. She got all excited, but then she realized it's closed. Huh. She just remembered they're closed.
Yeah. Mohammed, try the section 7.1 and 7.2 stuff again. I think that was an original problem from yesterday. I think Madison had pointed that out. 7.5.1 in view mode and 5.1, huh? Okay, let me double check 5.1. Yeah, try not to click on the, what is it, review mode? Because if you do, it won't let you use late passes. Oh. So videos. Okay, Mohammed, try it out again.
And people are protesting this shit. But they're all wearing masks.
How oxymoronic is that, right?
Yeah, they're like, no mask, no tyranny, but they're wearing a mask while they're
Yeah,
protesting.
right. During the protest, they're complying to what they're protesting against.
And like fucking idiots. I was
Right?
watching this. Yeah, I was watching this one thing. This lady in New York,
Yeah.
she cut a hole in her mask.
Oh yeah, I saw that. I went to go pay for something inside a drugstore or something.
Yeah, and he's like,
Oh
well,
my.
I cut a hole in it so I can breathe better. I mean, if you gotta wear it, just wear it. Who cares?
Yeah.
It's not like we're completely shut down. You can still
No.
go to the store. I mean, there's some things that you can't do. I understand, but
Yeah. Like I think it was, so maybe about so I haven't used my bike in like I haven't used my pedal bike, not a motorcycle, my pedal bike. I liked biking around. Actually, maybe up to about 2 years ago, I was getting to LMC on my bike in public transit. So I would show up to work on my bike. Up to about a week ago, I thought I wasn't able to go out on a bike ride. It turns out you can go out on a bike ride. You just you can't hang around
yeah,
in a specific, in one particular spot for too long. You just have to keep moving. I'm like, okay, that's exactly what I want to do on a bike anyway.
yeah, yeah. You can go out, but you just
Yeah.
can't like hang out. Like,
Yeah, you just can't hang out with other people, which is
I mean,
okay.
I got in trouble at Lowe's because I was browsing,
Oh, come on.
so they told me to.
Well, I went to Home Depot, so I put in that shader thing. I think I showed you guys, right? I put in this shader thing in my backyard. Like, well, it's not really a backyard. It's like my back patio, right? So that I have a little bit more shade, and it turns out it actually helps with the heat, like even during the day inside. And I went to Home Depot, and they already had a line going out the door. It was like I had to wait in line for like 20 minutes just to get in. And there were guys up front that were like, nope, you can't come in. You don't have a mask. Too bad. Bye.
It's not hard. Just wear a mask. Like, whatever.
Yeah.
Man, I went to Target the other day, and
Yeah.
it's no one's there, so who cares?
Right.
And how convenient! Like you can just go to Safeway and they put your groceries in the back of your car for you.
Right.
Everywhere delivers. Costco delivers.
Right.
Who cares? I don't know. People are complaining.
So today I have to do another Costco run. I'm gonna do it probably after my office hours at 3:00.
Yeah, they're I forgot, in Louisiana,
Yeah.
they were, I guess, a big, I don't know, it wasn't news, I guess, like a big protest went, because they opened up a half hour late,
Yeah.
and they weren't letting everybody in, and, like, they had to call the cops and shit,
Oh wow.
because people were outside. But it's like, we did that Instacart thingy,
Yeah.
and then there's these people that go shopping for you.
Yeah, I've seen that.
And so, like, they order from Costco, and, like, this lady and her husband went to Costco and bought everything for us.
Yeah.
So, I don't know. It's not very. Who cares? It's easy.
Yeah.
I don't know. I was trying to become an Instacart shopper.
You're gonna become an Instacart shopper?
Well, because I do the Uber and then the Lyft and the DoorDash sometimes.
Yeah.
And you can, like right now, you can make a lot of money. And
Yep.
you don't even have to go inside. You just leave it at the door. So it's not that hard.
Right.
And you can make a lot of money just doing that. But I was looking at the Instacart shopper. The problem is like if people want to do Uber right now, it would
Right.
take it would take forever, like Uber Eats and DoorDash, because they have to do a background check on you, and that takes 3 to 4
That takes a while.
weeks. Yeah, so it's if you already have it set up, that's why Instacart, the Insta shopper wasn't set up, so you can't do that. She's looking at the computer.
That's your daughter?
Yeah.
Oh.
I'll show you it.
I'll show you it. Why do you say it?
I'll show you it.
Are you not in class? Oh.
Yes, he's in class.
Yeah. I am in class.
I'm letting. Oh, look at that.
Oh.
Say hi.
I should put my face on. Come on.
Say hi.
He's like, what? She's like, what?
What's going on?
Yeah.
What is he doing? Come on, go on.
Must be nice to be a tiny poo right now. Just not worry about anything.
Yes. She doesn't know. She's like, both parents are home all the time.
Yeah, I know.
She's like, who cares?
Mm-hmm.
She could watch Frozen in 3 different rooms. No, you can't do that.
Yeah.
Yeah, but I was looking at the Insta shopper, but it's gonna take too long to set up.
Right. Yeah.
And that'd be cool, like to go to all the stores when no one's there. They let you in like a couple hours before it opens,
Oh, really? Wow.
and then you can go. You do your shop. They give you a.
You do your own shopping before anybody else gets to it.
Yeah, I guess you get dispatched, so they send you something, and then
Right.
which is cool. Like, and then you can like walk around and then see what's on sale and what's good, and then you can go back.
Yeah. Yeah.
I don't know. This stay at home is not even. I don't even care.
Yeah.
I don't know. I accomplish a lot of stuff, so.
Yeah.
Yeah, just the parks and stuff, I guess, they're closed, but
Yeah.
that's not fun. But That's impressive. Maybe now you can make an upside down U.
Making an upside down U.
Yeah, she's playing with the calculator.
Oh.
I couldn't find my calculator for how many weeks? This is going on like a couple weeks.
Yeah.
And I opened the cabinet, and it was in a pot with the lid
I wonder
off.
who did that.
I don't know. Like every time we look for something, we just have
Check
to
the
go.
pots.
Like, yeah, there was a remote control. There was my calculator. My
Oh, that's adorable.
I was like, ew. She's. What are you talking to?
that is that's classic.
Yep.
Yeah, where are my keys? I'll check the pot.
Check the pot. That's where they're at.
Okay. Okay.
She discovered the cat's outside, and they go up to her. She tries to pick him up, but she's like doing like a strong chokehold on him.
Yeah.
And she like, grabs him by the neck and like drags him around the yard. And
Oh boy.
The cats are just laying there like they love it. They're like, whatever. And she's dragging them across the ground.
Yeah, and the cats don't care. They just want the attention.
Yeah, they don't care. They think she's petting them or something. I don't know.
Yeah.
Whatever. They like it.
That's funny.
What?
All right. Master. I'm gonna book, actually. Great book. Four, one. Four, two. So one. Okay, so 2. Four, 3. Actually, fine. Yeah. Okay, that one over there. So Mohammed, that's fine that they consume your late passes because these are essentially late. So I just gave everybody 100. You should be able to do these again. So I unlocked video assignment 4.4, which was one of yours that was you had what's this thing called? You had hit review mode. Yeah. For let me see. Yeah. So you should be able to access all of them. Mohammed. Let me check 5-1. Nope, 5-1 is open, so you should be able to access them all.
Oh, I couldn't do chapter 7 or section 7 stuff because it was said it was locked.
Really?
This was a
Chapter
while
7
ago, but
stuff.
yeah.
Try it again.
All right.
No, I don't think it was going to ignore any of them. You guys had to do the assignments on them.
Oh, okay.
Yeah, no, I'm sorry, Jarek. This is for Mohammed.
Yeah.
So like I said, I can give you guys as many late passes at this point as you need, but you guys need to get them done. I need to assess your knowledge on chapter 4 stuff. So those are still due.
Okay. Chapter or assignment 7.1 wasn't opening for me, but now that it's late, I could use a late pass. So
Well,
that was the
let me
one I
see.
had problem opening.
That was the one that you had problems opening?
Yeah, now I can just use a late pass, so it's okay.
I can still move it since we're barely gonna finish 7-1. So don't use a late pass yet. Don't use. I mean, you should have like 400 of them at this point, but
yeah.
Okay, I don't need that one. Okay. Oh, are you talking about the video assignments or the actual assignment?
I believe it was a
It's the video
video assignment.
Yeah. So I'll do this. I'll move them to Wednesday or Tuesday. So tomorrow. There we go.
Okay.
Just make sure you get them done. So now you don't have to use a late pass on them.
Okay. Thank you.
Mm-hmm. And I'll move those back a little farther. Yeah. No, even I need use late pass for chapter 7, which were locked. I just moved them for chapter 7. That's fine because the at least the 11 late passes, those are fine because those are very late. So just use them up. You should have a bunch of them at this point. Let me see late passes. I mean, I'm not giving any points for unused late passes. Just use them. Use the late passes. Go roster. Yeah, just use them.
Quick question.
Yeah.
Does it have to equal 1 or
What do you
does it
mean?
always the sine squared x plus cosine squared x? Does it always have to
That is
equal
always
1?
equal to 1.
Okay.
Yeah. Just make sure you get them done by the end of this week. Actually, no, the online stuff you can take however long. I mean, don't take past past the end of the semester or past the final. The lecture questions I'm gonna have to make do. Make sure you have the lecture questions in. They weren't locked for the last couple of weeks now, almost a month.
Oh. Oh. Okay, another question. On the very first lecture question,
Yep.
it says cosine minus cosine to the third power. You can those two can what you call it go together, and that could be negative or negative cosine squared, right? No.
Mm-mm.
Oh.
So cosine cubed, right?
Mm-hmm.
And cosine. Those are two separate things.
Mm.
So you can't combine them. They're not common terms.
Okay.
But you can factor a cosine out.
Hmm.
You can factor a cosine out. Chapter 4 and Chapter 5 lab, those are from Chapter 4 and Chapter 5. But I made that lab an extra credit. So it'll show up as 0 points on your grade book, but the points will add to your lab section. If you finish Chapter 4 and Chapter 5, all those points go as extra credit to your lab section. So if you don't want to do it, it won't hurt your grade, which is good. But if you do it, extra credit.
Wait, what's extra credit?
The Chapter 4 and Chapter 5 lab.
Oh, okay.
So I just put them in yesterday. Those are online lab assignments, and I made them extra credit. Online video assignments you made? No. Just the Chapter 4 and Chapter 5 lab.
We find that in the courses in the math lab, right?
Yeah.
Okay.
Well, no, it's one of the assignments
Oh, okay.
that you have on Canvas.
Oh, yeah,
One
yeah,
of the
okay.
online. Yeah.
Okay, I'm stuck.
On which one?
The first one.
Okay, so factor out a cosine from both of them. On the
That's
left-hand
exactly
side.
why I'm stuck.
So how about this?
do I write
You,
every single cosine?
So how about this? Can you still see the screen?
Yeah.
Okay. Come on. So what I'm saying is factor out a cosine. So cosine of x times what gets left behind.
1 minus cosine squared.
Right. Right?
Yeah.
This is something nice.
I don't have to put anything on the other side, right?
No. So these are one of those. These are like those identities, right?
Mhm.
So you either turn the left-hand side into the right-hand side, you turn the right-hand side into the left-hand side, or you get them both sides, right, left and right. You turn each one of them into something common,
Mhm.
right? So in this case, the best way to do it is manipulate that left-hand side into the right-hand side.
How do you change this cosine to a sine?
Use your Pythagorean identities. Look at the very first page of the packet.
I have a question on the fourth one for number 1.
All right.
So I got down. So for the sine negative x, I made it equal to negative sine x. We can do that, right?
The first one.
I'm sorry, the fourth one.
The fourth one. Okay.
The bottom right, yeah.
Yeah. So this one, we did mention that this one was back in chapter 5, where you can do, so sine, right, of a negative angle, right, is equal to negative sine, right?
Yeah.
Of that same angle. So you can change that.
So I change that to 1 minus sine x.
Exactly.
And then I made that cosine x. No?
Not yet. So FOIL it out now.
Oh,
So,
FOIL it out?
Yeah.
Oh, okay.
Something nice happens.
So I couldn't, so if it's 1 minus sine x, I can't make it cosine? It has to be squared.
Right. Because your identity tells you it has to, the identity is 1 minus sine squared x is equal to cosine squared.
Okay.
Got it?
Yeah, got it.
Okay. Okay, be right back. Okay. All right. How did these feel for people?
I'm still lost.
For which one?
For the first one.
For the first one? Okay. So this is sort of you got to start getting comfortable with this. Okay? You can manipulate any one of the identities that already exist, right, into what you need to solve these problems. So the algebra, the arithmetic that you need to use to prove identities comes second to the reasoning behind it, sort of to the logic. Okay, so for this one, I'm going to manipulate this one, right? Sine squared of x plus cosine squared of x is equal 1. I'm going to manipulate this one. In particular, I want 1 minus cosine of x. So that's just minus cosine of x here. Right? Squared. Whoa. So then I have this now, right? Sine squared of x is equal to 1 minus cosine squared of x, right? This is exactly what I have here. So then now I can substitute that in and I get cosine of x times sine squared of x. Jarek? Did that make sense?
Okay.
Right? And it turns out we're done because we just finished it. So the idea is we either have to change the left-hand side into the right-hand side, the right-hand side into the left-hand side, or get them to a common point, right? In this case, we just changed the right-hand or the left-hand side completely into the right-hand side. We're done. We don't have to do any more than this.
Okay.
Notice, right, down here, this needed to happen. You wouldn't be able to continue with the problem if you didn't do this bit right down here. So that's what I'm saying. At this point, you guys got to start getting comfortable with that. Okay. Are you guys ready for 7-2? Seven two. 7-2. Okay. So like I said at the very beginning of the class, we're probably going to fly through these. Yeah, we're probably going to fly through these. Most of 7-2, 7-3, and 7-4, to an extent, are just equations. They're identities, right? That I'm just going to make sure that you know how to use, okay? And they have a use for them. They have a use in math. They get you angles that aren't on the unit circle with values that are, okay? They just get a little bit more complicated. So for 7-2, we have sum and difference identities. So if you have the sum or the difference of two angles and you want to find the sine or the cosine of them, you can do so using these equations. So these are the 6 right here. If you add 2 angles under cosine, and if you subtract 2 angles under cosine, add them under sine and subtract them under sine, and then add them under tangent and subtract them under tangent. Okay, these are those big ones. Okay, now, if you ever decide to, it's not a requirement, at least for this class. If you ever decide to, there have been many times in the class, not too many, but enough times in the class where I said, if you really, really, really want to find out where these things come from, go get a math degree. This is one of those things, okay? The proof of them, you probably, if you sat there for a good hour or two, you can probably prove these and run through the proof. It's very elegant. It's very, it's very beautiful in a mathematician's eye because it uses a lot of cool stuff, okay? Thankfully, though, I'm not going to cover it. I'm not going to do the proof, okay? If you do want to look into it, you guys do remember we have a textbook for the class, right? That's also in your files. You can go ahead and look in through the textbook. It's actually in section 7.2. Okay, so for now, I'm going to skip them. Okay, I just want to be confident and comfortable in the fact that I'm going to show you guys how to use these in particular. Okay, so just going to use it as we would for this, right? So exact value of cosine of 5 pi over 4 minus pi over 6, okay? I don't care what that angle is for now, but I want the cosine of it, right? So this is the subtraction of it, so I need the subtraction of it here. So I need that one, right? So cosine alpha, cosine beta, sine alpha, sine beta. So I need to assign my alphas and betas. This is going to be my alpha, and that's going to be my beta. Make sense? So then now, let me actually write it over. Alpha is 5 pi over 4, and then the beta is pi over 6, right? At this point, it's plug and chug. I'm just going to use the equation flat out. So this is going to be a cosine of 5 pi over 4 cosine of pi over 6. Okay, and the rest is plus sine alpha sine beta. So plus sine of 5 pi over 4 sine of pi over 6, right? Now I get to jump over to my unit circle. So cosine of 5 pi over 4 where's 5 pi over 4? There it is, root 2 over 2, negative root 2 over 2. Okay. So this is going to be, actually, let me write it below it so I can show you guys what's going on. So this is going to be root 2 over 2. This right here is going to be root 3 over 2 plus, and there's a multiplication in between, right? Sine of 5 pi over 4, that's going to be, oh, and this is going to be negative root 2 over 2. Negative root 2 over 2 times, this is going to be 1/2. Got it? At this point, it's multiplied straight across, right? So then this is going to be negative root 2 times root 3 over 4 plus negative root 2 times 1 over 4, right? And this is going to be negative root 6 over 4. Root 6 over 4 minus root 2 over 4, right? And then I can combine these two under 1 square root minus root 6 minus root 2 all over 4. And we are done. This is our final. Okay, now I just picked root 5 pi over 4 and pi over 6 just out of the blue, just so I can show you guys what to do, right? Now, they're much more these equations are much more useful in scenarios like this one, right? Find the exact value of cosine of 75 degrees. Okay? Here's the portion where you need to go find the two angles that sum up to 75 degrees, okay? And those are pretty easy. So I can do cosine of 30 plus 45 degrees. So notice 30 degrees plus 45 degrees is 75 degrees. So now I can construct the values for 75 degrees by using the values for 30, and 45, right? Since this is an addition, right, I'm going to do the cosine of the addition. So it's this one. So cosine alpha, cosine beta minus sine alpha, sine beta. So this is going to be equal to cosine of 30, cosine of 45 minus sine 30, sine of 45. And these are all degrees. Okay? So now, I'm going to show you guys what each one of these is equal to. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. These are all from the unit circle. Sine of 30 is 1/2. And sine of 45 is root 2 over 2. Multiplications in between here, and then there's the subtraction in between those two. So now I get to multiply through. Root 6 over 2 minus root 2 over, over 4 over 4, right? So then this is equal to root 6 minus root 2 all over 4. And we're done. Notice how these work. These are just plug and chug. The hard part is this part right here. We needed two angles that added to 75 degrees from our unit circle. Okay. After that, it was plug and chug. Okay, so let's go ahead and do, groups for these. I'm going to give you guys maybe 5 minutes to find out your corresponding value, and we'll come back and compare all our answers, okay? Bryce, Diego. Are these working out a little better?
I think I understand it.
Okay. So what did you guys got? You guys are group 3, so you got sine of 345, right?
Am I on the wrong page? Isn't it the third one sine 330?
It's 340. So change it to 345.
Oh.
330 actually exists on the unit circle. I wanted to make it a little bit more interesting.
Okay. Okay, now I got to start all over.
Yeah. So what two angles add to 345 that you know are on a unit circle?
That's a good question.
Yeah. So two angles that add together to make 345. But you know that these two angles are on the unit circle. What was it, Diego?
345.
Done.
That's what I thought, but I wasn't confident in myself, so I didn't say anything.
Oh, you should have said it. Like I said, that's the hardest part, figuring out. Sometimes, you know, you have to sit there and like, what two angles making it? And sometimes they're easier than you think. So 345. Go off with that.
Okay.
Okay. I'm gonna go bug another group.
Okay.
Okay. Is this stuff working out a little better this time?
I think it's pretty easy. Like you said, you just plug it in and solve.
Mm-hmm. These are the plug-in chugs.
Mm-hmm.
Okay, I'm gonna mess with the other group. Thumbs up, thumbs down. This stuff a little easier. And silence. Ignacio, Madison.
Good.
Good.
Yeah.
What'd you guys use for the sum?
I use 45 and 60.
Which one yours? What was yours? 105, right?
Yeah.
Yeah, 45 and 60. Boom. Okay. You guys are set. I'll bring you guys back. How did that feel for people? Did that regain everybody's confidence? So it's a little easier. This is the sections that are a bit more plug and chug than usual. So this section tends to be, like I said, more plug and chug for you than usual. something you don't see very often once you get the trig. So yeah. Okay, let's go ahead and run these through really quick. Let me share my screen first. So for 105, what'd you guys use for the sum? So I'm hearing telepathically that people are saying sine of 60 plus 45 degrees. I hear you. I hear you. Okay. Right? So at this point, we're just going to go right up back to the top. So we need the sine addition one, right? So sine addition. Boom. So sine alpha cosine beta plus cosine alpha sine beta. So this is the one that oscillates between the two. So then sine of 60 cosine of 45 plus sine of 45 cosine of 60. Right? And it's the addition. This is the thing I hate about this one, or these. That's why I never make you guys memorize these. These are always, you have the trifold, so you just use the trifold over and over and over again, right? So sine of 60 degrees, that is root 3 over 2 times cosine 45, root 2 over 2 plus root 2 over 2. And then cosine of 60 is 1/2, right? I know some of you guys are like, well, all of these are the same values. Yes, for the most part. They just oscillate between negatives and positives. So this is going to be root 6 over 2 minus root 2 over 4, sorry. And that's a plus over 4. So root 6 plus root 2 over 4. And there we are. That's our final answer. Why do we use cosine as it says only sine of 105? So this one was just sine. The next one over is cosine. So same idea. Whoa, I didn't use green. Okay. Cosine of 60 plus 45, right? So now we need the cosine addition one. I think those are the ones that are matching with the negative in between. Yep, there it is, this one. So alpha, beta, minus. Okay, so this is going to be cosine of 60 degrees, cosine of 45 degrees, minus sine of 60 degrees, sine of 45 degrees, right? There's a minus in between. So then cosine of 60 is, this is 1/2 times 45 root 2 over 2 minus sine of 60 degrees, that is root 3 over 2 times root 2 over 2, root 2 over 4 minus root 6 over 4. So root 2 minus root 6 over 4. You guys see how these work out? Stop me if you need me. So if you take a, if you notice, right? Let's go ahead and do some unit circle sort of analysis on this. This number is going to be positive. This one's going to be negative because root 6 is much bigger than root 2, so it's going to be a negative number, right? So if we check on our unit circle really quick, if we check on our unit circle really quick, 105 is actually just a smidge past 90 degrees, right? So our y should be positive, but our x should be negative, right? And lo and behold, our cosine is negative and our sine is positive. So we're good. This is actually working out, right? So this one, I'm just going to go ahead and write this out. Sine of 300 plus 45 degrees. Okay. For group 3, what'd you guys get?
Is it square root negative 6 plus square root 2 over 4?
2 over 4. Yep. In the interest of time. Okay. And then the cosine, since we're short a couple people for a 4th group, square root of 6 minus square root of 2 over 4. So I went ahead and did this one so I can have all 4 so we can have all 4 values. Okay, so now we have sine and cosine of 105 and 345, okay? The tangent ones are innately a little bit more difficult because you need to find sines and cosines of them first before you do the tangents, right? But they work out the same way. I know we can grab, so we have, let me actually write these out. So for this one, we know we can do sine of 105 divided by cosine of 105, right? And likewise for the one below it. Oh, it's gonna crash, it crashed. Okay. Sorry, you guys, my thing just doesn't want to cooperate. So I know we can do sine of 105 divided by cosine of 105 for tangent, right? And then likewise for tangent of 345, we can do sine of 345 divided by cosine of 345, okay? We can do this, right? However, I don't want to say that's no fun, but it's no fun. I want everybody to try their problem, so they're assigned, but I want you guys to use these two. In particular, this one, right? Because they're both additions. Okay? And you guys are supposed to get the same answer either way. Okay? So I want everybody to try this out down here for these two, okay? So groups 1 and 3 are going to do the very first one, and then groups 2 and 4 are going to do the bottom one, okay? One last time, we're going to go off in our groups. Oh, nothing is showing, sorry. Okay, so like I said, for these, we can do sine of 105 divided by cosine of 105, and sine of 345 divided by cosine of 345. That's perfectly fine, but I want you guys to practice the other ones. So there are tangent sum to product identities, these two, okay? I want you guys to practice with this one right here. Either which way you want to do it will get you the same answer. So this is just purely for practice on doing this method right here, this one, okay? Just so you know how the alphas and the betas work, okay? Okay, I'm gonna shove you guys into groups one more time, and we'll go over them in about 5 minutes. And after that, we'll be done for the day, okay? Okay, last time, last breakout groups, I swear. Thumbs up, thumbs down. Silence. It seems like it's the end of the semester. You guys are just like on your last leg. I don't blame you guys. Yeah. I've had to go back to so usually right after your guys' class, I have a bunch of stuff that I need to do. I have like a little 45-minute break for myself in my class or in my office. And then I go to my lab hours, then come back, do office hours. During those office hours, I have myself a cup of coffee. I've noticed I've been getting tired recently. Like, why am I getting so tired? I was usually awake at home. Coffee was the difference at that specific time on top of that. So maybe some coffee. Oh, I'm sorry to hear that. Is friend grandma doing okay? Or is it COVID? I've had a couple stories from some of my students in the other my other classes that they've had friends and family members go in for COVID treatment. Oh man, fucking cancer, stupid cancer. That's sad. Oh, that's horrible. It's stage 4, so yeah, there's no coming back from that, unfortunately. Well, just keep I guess keep the kids in high spirits, I guess. That's all you can do. I'm gonna go bug another group really quick before I bring you guys in. Thumbs up, thumbs down, thumbs middle. Thumbs up, thumbs down, thumbs middle, thumbs middle, thumbs middle.
Oh, the middle. We're supposed to find the top and bottom first, like the sign separately, and then we move it to the tangent.
Right. So what I want you guys to do is you guys see how oops, sorry. Let me show you guys my screen. So tangent. So you guys are what group? Group 2?
3.
3. So you guys have to do sine of 105. So actually, sorry. I wanted you guys to practice the using the formula from above. So and that's the tangent alpha tangent beta divided by this one. Let me show you guys the, ooh, too far. That one. Right? So and that meant, so the two angles that you guys had were 60 and 45, right?
Yeah.
So and that meant you had to do, what is it, tangent of 60 plus tangent of 45 divided by 1 minus tangent 60 times tangent 45. Does that make sense?
Yeah.
Is that what you guys did, or you did it some other method? Or did I just lose you guys?
I think I'm lost. I don't know.
Okay. All right. So it's about that time. I think we did enough for today. I think I'm going to call you guys back in. We won't do this today. I'm just going to let you guys go. And we'll pick this up on, what day is that? Wednesday? Yeah, Wednesday. Cool.
Yep.
Okay, let me bring you guys back really quick. Cool. Okay, 20 more seconds, and everybody should be back in here. There's not too many of you guys left. Okay, so these kind of stumped people. So what I'll do is, it's already 12:20. Don't want to keep you guys too much longer. It's such a pretty day outside. We will start here tomorrow or Wednesday. Okay. If you guys want to try it on your own after that, or after right now, that's perfectly fine. You'll have something. But besides that, I think I'm gonna just let you guys go. Go off, be free, have fun, enjoy your Monday. Such a beautiful Monday. Enjoy your Monday. I'm gonna stick around just for a little while because I need to go eat. So that means I need to go get food. Besides that, I'll see you guys all Wednesday. Yep, you too. As fun as it can be. Locked up all alone.
Yeah, before I go, I was going back and doing old video assignments, and
Yeah.
for video assignment 4.2, the due date for me says March 13th, but in 2018.
Oh, yeah, that's not supposed to be there. Which one was it? March?
Video assignment 4.2.
It's video assignment 4.2. I think that's what Mohammed was saying. Let me see. That is definitely not what I wanted. Assignments. It was the video assignment for 4.2, right?
Yeah.
Video assignment 4.2. Yep, there it is. Okay. All right, that should fix it.
All right, cool. See you on Wednesday.
Yep, see you Wednesday. Mhm. All right, Joe. Hey. Halfway confident. Do you want to move it to Friday, or I don't think put a dent on. All right, you put a dent in the videos. Do you want to move it to Friday so that you can have like a good? Okay, all right. It's better actually to move it to Friday because I'm not in. I would want you to take it at the same time that I'm present, right? And that can't happen until Friday. Otherwise, we'd be really tight. So we'll move it to Friday, but I don't think I can push it back farther than that. So, yeah, actually, that might be better. You know why? Because the due date for that stuff is this Friday. So, yeah. Cool. Sounds like a plan. And I'll see you on Friday then, or well, Wednesday. And then we'll do the, yep. Okay. I'll see you around then, man. Have a nice Monday. Cool.